Hey, hello, we are the Nielsen Group at the University of South Florida. My name is Daniel Ashley.
I'm Justin Fonestock.
I'm Michael Gallis.
And I'm Alexander Rakatan.
There are 5 main requirements for this project. The first one is to design and conduct experiments to determine battery use and accuracy of Android location services. The second one is the ability to detect movement of a user using the phone's accelerometer. The third one is to create an algorithm capable of detecting points of interest with less than 15% of battery use for 8 hours, and accuracy no worse than 5% false positives and 5% false negatives. The fourth one was to create a sample Android application which would utilize the algorithm. The fifth requirement was to create an algorithm that may be customized to sacrifice battery life for higher accuracy. This is the route we will take to demonstrate our application. It will start at the S and pass 5 points of interest. We should only hit the first 4 points of interest because the fifth one is intended to be out of range. We will also repeat this test with GeoMemo and compare the results. As you can see, we are passing a Publix right now. Let's look at Arrow. It indicates that we have visited the point of interest by marking it with a pink balloon. You can also see that we have red and blue dots and a blue balloon. The red dots are GPS pools, while the blue ones are network pools. The blue balloon is a point of interest that has not yet been visited. Since the starting point of this trip is the southernmost red dot, we have not visited that point of interest. Let's continue our trip. We are passing another point of interest, which is another Publix on the left. We are passing our third and fourth point of interest, which are a Publix and a Walmart. Arrow will be able to mark both points of interest, even though they are very close to each other. There's a point of interest being a Publix ahead of us on the left before we make the right-hand turn. This point of interest should not be visited as it is not visible to us in the car. As you can see, we have hit all of our expected points of interest. Notice that there is no unnecessary GPS pulling done between the large gaps between points of interest, and the frequency of GPS pulls increases when we are close to a point of interest. We will now test GeoMemo on the same route with the same starting point, endpoint, points of interest, and detection radius as Arrow. After driving past the first point of interest, GeoMemo fails to register that we have visited the point of interest. After finishing this route, GeoMemo only detected one point of interest, which was the second point of interest. We will now put the two routes side by side to compare the results. Arrow was able to accurately visit all expected points of interest, while GeoMemo only visited one. With this test, Arrow's accuracy is 100% compared to GeoMemo's 25%. As for battery usage, both applications use less than 0.5% of their battery power in the roughly 20-minute drive.